Alrighty, welcome back everybody. For today's video, we're still in the pre-security area. We're still in the introduction to cybersecurity, and we are going over defensive security intro. So much like the offensive security intro, it's just a basic brief overview of the main security topics that get applied to the blue side of the house. So with defensive security, there are three task areas. This one I actually like because we get to do a little built-in exercise, and that's really where I think TryHackMe gets a lot of value from. So starting off, it just goes into the basic introduction of defensive security, and it's all about the two tasks of preventing intrusions from occurring and detecting intrusions when they occur and responding appropriately. So I really do like this little image right here, this little GIF, the animation that's playing, because it's showing there's not one single layer that's going on. As we go through more and more of these courses, we're going to start understanding all the different tools and their responsibilities, where you might have an endpoint that's running an antivirus with its own rules going on, while it might be talking, communicating with the server that has different sets, and then on the network and everything. So I like this little animation. I thought it's a nice quality one. These main tasks right here that revolve around defensive security are very important to also understand. So, user cybersecurity awareness. A lot of roles in IT, you are kind of, with exception like help desk and desktop support, things like that, you're kind of isolated to amongst you and your peers. But while on a defensive security side, there is always that active component of teaching your users, business partners, whatever you want to call your customers, about security. So whether that's training campaigns to go over, like you do phishing campaigns to teach them, as well as, maybe it's quarterly uh, talks where you are going over new topics with them. There's annual training. So there is a good amount of back and forth for being a typical IT related career. You can still interact with customers. I know in my day to day, I do that quite often, not only with the training, but reaching out and actually talking to people and explaining to them, hey, you reported an email. Yes, this one was good to go. This is why it was good. I understand why it might have looked a little bit fishy. Like, you guys still doing what you guys supposed to be doing, submit them, but trying to continuously educate people as their jobs stay the same while threats evolve all the time. Let's see, documenting and managing assets, updating and patching systems. That's a huge one. Vulnerability management in itself. I come from more of a desktop support background, so I am very entwined with the enterprise's remediation towards endpoints. A lot of working with Configuration Manager, Intune, um, other MDM solutions, things like that, as well as scripting to ensure that the patches are doing what they're supposed to be doing and assisting teams in their remediation. Let's see, setting up preventive security devices. So IPSs, IDSs. So um, this is more on the network side where the traffic can be properly analyzed. Say, hey, we have all these packets that are going to, this country that might not be so favorable to be working with. And why is traffic going there? Why is traffic going there at 3 a.m.? All these things you can set up for rules to help assist you, to prevent intrusions from occurring. And then setting up logging and monitoring devices. So your SIEMs, there's a lot of them. I know through these courses we'll be going into Splunk, which we'll be doing a lot of monitoring and such and going through logs. So I'll wait to dive into that at a further talk. But let's see, we'll also be covering Security Operations Center, that's known as a SOC. You have threat intelligence, digital forensics and incident response, and malware analysis. So all these, I know we're throwing a lot of vocabulary, a lot of stuff. If you're not familiar with, you might be like, okay, why are there so many different things working in conjunction here? It's because it is a fairly complicated landscape. But going back to the careers, most careers don't do all of it. No, you're going to specialize in one role. So if you're, and let's say you're the security analyst, You might just be working in a SOC, things like that, while threat intelligence might not be part of your job duties. Digital forensics and incident response, that you might, go a little bit into that, but there's full fleshed out careers for each one of these. So let's just go ahead and answer the question, which is which team focuses on defensive security? I know we kind of mentioned this earlier. There's a red team, and what color are we going with? This is the blue team. So we're just going to go ahead and type out blue team. Bam. Very good. Moving on to task 2, which is areas of defensive security. So now we're diving into those 4 topics that I just kind of brushed up on. So the Security Operations Center, threat intelligence, digital forensics and incident response, and malware analysis. I'll tell you right off the bat, malware analysis, I'm not super involved with or engaged with in my line of work. So I'm going to read through that very, very much just so I'm on the right page and I'm telling you guys bad stuff here. So Security Operations Center, that's the team of cybersecurity professionals that monitors the network and assists them to detect malicious cybersecurity events. So they're looking for vulnerabilities, policy violations, unauthorized activity, or network intrusion. So go ahead and read through what all these actually, word for word is talking about. I trust you guys can read. This image right here, where there's tons of screens and, people are looking at the grass and they're looking at the map, the globe's up here and there's the red lines and everything. In a sock, yeah, they can definitely have that. Not everyone has the staffing to provide this for the organizations. So there are companies that this is what they do for other organizations. So was it MSSP, things like that. Um, Smaller companies can just outsource this, but in in my line of work, no, we don't have a wall full of uh, monitors alerting us this and that. I mean, I work remotely most of the time. I do have a good array of monitors, and there will be different dashboards and screens up, things that I'm particularly interested in. I'm tasked to be responsible to look over, but a lot of my work has to do with setting up all the proper logging and setting up, you know, proper monitoring devices that will report. And then if I need to go in further, I can to properly investigate whatever I was looking at. So threat intelligence is pretty cool because it's all about gathering information from actual and potential enemies, um, going into basic vocabulary here. So intelligence is the information that you're gathering about them. A threat is any action that can disrupt or adversely affect a system. So threat, you're going to hear that a whole bunch. Intelligence, you're going to hear it a whole bunch. What's crazy is the amount of different organizations, the amount of different tools that are providing threat feeds. So there's the whole topic of threat intelligence. I'm not out Googling, you know, trying to track down somebody from North Korea or Russia to figure out what their whole attack chain looks like and everything like that. No, I'm I'm subscribed to different feeds, and from that information that I'm getting, I will then read through them, say, okay, I need to now maybe apply this filter on the tipping point device that is talking about what this threat feed is warning us about. Or, maybe there's a government published document that's saying, here's some bad guys that we found. Here's how their attack chains work. Here's what you guys need to be looking at defensively to implement. So in threat intelligence, there's a whole bunch of careers, really cool careers where they're actively figuring out all the steps and publishing it. For me in my job, I'm relying on their data, and my organization is relying on me to use that data to protect the organization. So it's never a dull moment. It really isn't. And then, we're talking about data over here. So data has to be collected, possessed, and analyzed. Network logs, public sources such as forums. I can't tell you how many times I've run into random stuff where here's a threat feed. And then you'll see an accommodating post like on Reddit or something that's also going into the topic. So it's fun. People on the internet talk, use whatever is useful as long as it's from a somewhat reliable source, because you definitely don't want to be listening to bad guys telling you guys not to, hey, don't enable this. It's bad for you. Meanwhile, that's what they're using as their initial vector. And so, um, digital forensics and incident response. Oh boy, this is a fun one. Digital forensics, y'all ever see NCIS or CSI where somebody's going through a device, or they're to pick up chat messaging logs from whatever device that criminal has. There's full-blown careers, law enforcement that definitely uses this. um, if your organization might have a legal component, they might require digitally capturing devices in order to potentially mitigate litigation later. But this whole topic right here, it is very deep. I don't go super deep into that in my day to day, so I'm not going to speak like I know super much about it. But it is extremely interesting to know how different devices and how different like operating systems will try to protect their data. So, in a free software autopsy you can run on Linux, so you can put that on a USB drive, plug it in, and that can create a capture for you. Um, but like, I'm kind of showing my age. Old iPods, you used to just plug in, and it would say, it's a USB device. You could drag and drop songs in there, and then Apple decided, no, we're not really going to. We're going to put a whole bunch of steps to prevent that. So, suddenly you had to sync through iTunes, and now it's a full blown, you're kind of fighting with Apple in order to get what's off of a device, because Apple's philosophy is much more of enabling the user, which is great for modern day consumers. Enterprises have to deal with it. But like for the companies, there are companies that have wonderful engineers like Cellubrite, where they are pretty much going neck to neck to figure out what is the best way to capture to create a digital copy of, like, in an iPhone or an iPad, so the iOS devices. um so that's not free. Like, their suite of stuff is not free, but it is crazy to see kind of the cat and mouse game that goes on with that. So there's a lot more into digital forensics. Kind of went down rabbit hole, sorry. But moving on to incident response, which has four major phases of incident response, which we'll go over in this. But the main vocabulary here is, and it is a very important vocabulary piece to know, is incident. So an incident usually refers to a data breach or cyber attack. However, in some cases, it can be something less critical, such as a misconfiguration, an intrusion attempt, or a policy violation. Be careful with what is referred to as an incident versus what is referred to as a breach versus what's referred to as a cyber attack. Depending on your organization, that can launch completely different methods of triage. There could be legal that needs to get involved for one, but not the other. Public affairs might need to be involved in one or the other. And a lot of these things, they all sound scary, especially to people not in the field. So for our case, we're learning right now. This definition works absolutely fine. You know, we're just starting out. So an incident could be anything like a data breach, cyber attack. It could also be less critical things. So they do go into several examples here, which I think are great examples. So let's see, making network or systems inaccessible, defacing the public website. Was it the Dodge website got defaced pretty much as soon as that thing went live? Data breach, so stealing company data. So they asked you, how would you respond to a cyber attack? And if you think about that, there's probably a million different things going on. You want to answer who, what, where, when, why. You want to stop it. You don't want it to continue spreading. You want to do your best to reduce whatever damage is going on and get the organization back up and running in the shortest amount of time possible. So This right here, you would ideally develop a plan that is ready for incident response. So it's an incident response plan. And your incident response plan does not need to be something specifically tailored for, user clicked on this email, 85 bajillion different steps. It can be a broad approach as long as the main fundamentals are there to cover all the bases. So in this case, we're going to go over the major four phases of incident response, which is preparation, detection analysis, containment, eradication, and recovery, and post incident activity. So, preparation, I'm going to read just through here, and if I run on, then I run on. All right. So, preparation, this requires a team trained and ready to handle incidents. Ideally, various measures are put into place to prevent incidents from happening in the first place. So, this could be implementing new firewall rules, preventing certain EXEs from executing, things like that. If you notice, this leads into detection analysis, but it's a cycle. So the final phase, post incident activity, leads right back into preparation. So it's full circle. All right, next, detection analysis. The team has the necessary resources to detect any incident. Moreover, it is essential to analyze any detected incident further to learn about its severity. So let's say the incident, a user clicks on a bad email, and from there they download an attachment and the attachment runs. Alrighty. From there, we're wondering what email, who else got the email? Do we have the tools to then remove the email to prevent other people from doing it, from clicking on it and actually launching whatever was launched? We need to figure out the what actually launched. Was it moving lateral? Was it trying to grab credentials? What actually happened when they executed that? S- So just the detection and analysis portion is trying to figure out how bad it could be, as well as what kind of scope are we talking about, as well as using the necessary tools that hopefully will pick up on it. All right. So then we have containment, eradication, and recovery. So kind of the meat and potatoes, where let's see. I'll just read it. So, once the incident is detected, it's crucial to stop it from affecting other systems, eliminate it, and recover the affected systems. For instance, when we notice that a system is infected with a computer virus, we'll likely stop or contain the virus to prevent it from spreading from other systems, clean the virus, so eradicate the virus, and then ensure proper system recovery. So, in that earlier example that I used, somebody clicking, you know, and it could potentially spread. So in terms of containment, going into your proper tools to remove emails from other people so that we know, okay, the email went out to 200 people. We've removed it from 200 people's inboxes. Great. How many people actually engage with it? We need to find that out. Maybe your tool has a function that lets you see that. Maybe you're emailing people. Each instance will be different for the actual execution of it. So you have a file, you can figure out what its hash is. So you get a SHA value from it, and then using your tools prevent that from executing in your environment everywhere, and then doing a scan using those values to make sure that your environment has it properly cleaned up and eradicated. And then for recovery, at that point, if you've already stopped it from going places, if you already removed it, recovery, it's pretty much, hey, is the system good to go? No other further issues are coming from it. Personally, I would probably put a tag on that device to kind of be more alert of it in the following weeks, just to make sure no funky business happened that we just didn't see initially. Because you can run through the logs, but I'll tell you right now, computer like device logs, there's so many entries. It it is a very unique skill to be able to properly and effectively find the information that you're looking for. And then you have post incident activity, which is one of my favorite things. You get to produce a report and then the lessons learned and shared to prevent similar future incidents. And that goes right over to preparation. So I love powwows. I love whatever you want to call them, hogwashes, powwows, after action report, where you go through and you get to say all the actions that were taken. You give a timeline. What did we do? What do you know? Did we do anything bad? Could we do anything better? Usually there will be some improvements just because there's so much going on in an enterprise. There should always be improvements, whether it's just communication, whether it's tying it to user awareness training. Maybe that email that initially went out, we could then go ahead and make a phishing train campaign based around that email. So at least everyone knows what it should be looking like. And then we got malware analysis. So malware stands for malicious software. So software is your programs, apps, documents, files that can be saved on disk or sent over the network. Malware could be there's a whole bunch of different types of malware, but could just be a virus that attaches itself to a program. It could be a Trojan horse where it's faking kind of what it is, making reference to the Trojan horse um, way back in the day. And then there's ransomware, which I'm pretty sure everyone has heard of that term, but it encrypts users' files. And then the bad guys say, hey, we'll give you the key to decrypt your files and pay us money. Um, you know, that can cripple a whole enterprise if they're not set up for proper backup and recovery. It gets horrible. It's extremely horrible when like the medical, like if a hospital gets hit by ransomware, because then actual lives are at stake. So, going into the actual analysis of it, there's two main means to get through it. There's stack analysis, which is uh, you're inspecting the malicious program without running it. So you need to have a solid knowledge of programming, particularly in assembly language. So this defines assembly language as like the computer's fundamental instructions. So instead of for if you know anything about programming, I'm not a programmer. Okay, I'm not, but object-oriented programming where I can set up variables to say, hey, me, Quincy, set that as name, da da da, and have me execute whatever function, wake up, compared to like what the machine code actually is to tell a computer to do that. It doesn't even look like readable English, but hey, there's extremely intelligent people in this world that have that skill set, more power to them. And then we have dynamic analysis, which works by running the malware in a controlled environment and monitoring what it's actually doing. So two different ways to look at malware. If you're going to do any of that, please do it in a sandbox. But let's go ahead and get to the questions. So, what would you call a team of cybersecurity professionals that monitors the network and its systems for malicious events? All right, give you a little second. It is that three-letter acronym. It's the SOC. So we're gonna go with Security Operations Center. Boom. And then pretty much we're doing a vocabulary check right here. So what does DFIR stand for? Remember, it's like two words. Then we have and right here, and then two more words. All right, it is digital forensics and incident response, if I can spell right. Awesome. And then which kind of malware requires users to pay money to regain access to their files? So we only talked about like three different types of malware. We had a regular virus, a Trojan horse, and ransomware. Trojan horse typically does not encrypt everybody. I'm not saying that it can, but typically if we're classifying it as one that is actually encrypting software or a whole device, so your hard drive, all your storage and everything, we're talking about ransomware. Alrighty. And finally, on to task three, which is the fun part. Oh, whoop, whoop. Your answer is correct. Alrighty. So we have a scenario here. So let's pretend you are a security operations center analyst responsible for protecting the bank. This bank SOC uses a security information and event management tool, SIEM tool. This will be your best friend if you work on the blue side. It really is because you get to configure it and it will alert you. It gives you what's important because you're telling it what's important to look for, and it will help you out so much because there's way too much information otherwise. Without that, it just makes life a living, yeah. So it puts it all into one dashboard. This is a really funny image, but yeah. So you're gonna have alerts. You're gonna have use your account login stuff. So Bob failed to make five, or Bob made 5 login failed attempts. What's going on with Bob? Was that actual stuff? So you dive in there and say, okay, it's from his work issue device. It was first thing in the morning after, a long weekend. Turns out Bob just forgot what his password was. So then he had to go and reset it or something like that. Danny executed a binary file called image.jpeg.exe. Well, that was crazy, Danny. Why would they want to do that? Because if it's an image, it would just be a JPEG. Typically, your images aren't executing files. Or like Alice logged in at 3 a.m. What's Alice doing when her shift's 9 to 5? So alerts like these, your team will report on, and it is the members of the SOC that need to dive into there and make sure that it is normal, expected behavior. Or if not, look into it and conduct actions to remediate whatever just happened. So this right here is a very thing. Not all alerts are malicious because there's so many. Um, and then we go into examples. I kind of already hit on that. Talks about IP addresses, but that's kind of what this exercise is going to do. So we are going to go ahead and click on this and do this little simulated interactive exercise, which I really enjoy. So we are a day in the life of a junior associate security analyst. All right. So inspect the alerts in your SIEM dashboard, find the malicious IP address from alerts, make a note of it, and then click on the alerts proceed. So we're trying to find an IP address that ain't right. Okay. It's not normal operating stuff, and we're going to make note of whatever it is. So let's go ahead and look over here. So we have our little dashboard. We have, probably where the traffic's coming from, things like that. And if you notice on this date, it goes from the past up to the present, okay? Or kind of past to as close as you can, closer to it. So we'll start with the first one, which was a login failure. Okay, but their account password has expired, so they probably just had to set a new account. We had multiple failed logins from John Doe. Then John Doe logged in successfully, and okay, that's pretty fine. Boom. Then we have right here an unauthorized connection attempt, and you notice that one's red, so that's kind of a good giveaway of what's going on. So an authorized connection attempt detected from IP address 143.110.250.149 on port 22. Oh my God, I did not get to copy that. All right, and then okay, I'll just write it over here, over on my side. So 143.110.250.149. And then if we're looking at it, the next one, it was a successful SSH attempt. So a couple minutes later, 3 minutes later, so they were able to successfully SSH in. Alrighty, so what's going on with that? So let's go and click there. We're now on a website that will check IP addresses. This is Simulate One. We'll go through probably in another course what some good ones to check IP addresses from, such as like Aaron.net. So we go ahead and put in our IP address, and it will report on it. Hey, this is malicious. This is from China, from this domain name, this ISP. So I probably, yeah, we need to put in a rule to probably block that. All right. So reading through this, we're talking about escalating it. So we're declaring this a small incident event, and we want to escalate it now. And we're trying to figure out who to escalate it from. So we have Dominic Nash, who's a sales executive, Nadia Watson, who's a security consultant, Carolyn Stone, who's an information security architect, and Will Griffin, who's a SOC team lead. So just from there, we're like, oh, there's an incident. We have to keep it properly in scope here. Alrighty. So we probably want to end up blocking this. A sales executive probably does not need to be involved in that chain. A security consultant, it has security in its name, but consultants typically either a third party or something like that who is not necessarily in your chain. It might be higher up in the chain, as well as the information security architect. Like they're helping set up the SIEM and the network and everything, but they're not exactly working on that piece where it's just a normal escalation. So your SOC team lead, because we are a junior security analyst, is probably going to be our best bet. So let's go ahead and choose Will. Cool. And now we have our firewall block list. So if you look, we have 3 entries here, 2 from June, 1 from July of IPs to block. We're going to go ahead and put in our block IP address. We're gonna hit block, and now we have a flag. So we copy that flag, and that is the answer to that. So congratulations, everybody. You did it. Thank you very much.